In the second module of this course, we will start talking about possible levers for business process improvement, focusing in particular on how information and communication technology can support performance improvement of these business processes. These are the arguments on which we will concentrate our attention, and first of all, we will talk generally about possible levers for improving business process in their flow and functioning. As business process management acts through organizational, managerial, and technological variables which describe the functioning of the process and influence its performance, in order to improve this performance, we need to work on those elements. Following this rationale, a diffuse framework identifies in flow of activities, organization, resources and capabilities, performance planning and control, and process technology as the common lever for business process improvement. And now we will go in detail through each of these pillars in order to understand how to improve process performance and process functioning by moving some of these levers. First of all, we have the flow of activities. When we talk about the flow of activities, we think first of all about how the process flow is structured, meaning that all the activities need to bring value to the process flow, that the flow should be result as linear, and parallelization and overlapping of activities should be made by not bringing more complexity, despite design for improving process performance. For example, parallelization and overlapping can be very useful to improve the overall time to duration and time performance of the process. If one of these conditions is not verified, a good suggestion is of course to review the flow of the process and the logic sequence of activities, starting from, for example, the business process diagram that we have learned to design using some modeling tools. But we should also look at the logic and the procedures used in managing and executing these activities, like how these activities are controlled and supervised, which is the level of standardization in their execution, and which part are customer-based, namely pull, or forecast-based, namely push. The second lever relates to the organization. When we talk about the organization, we include aspects such as if the process owner is present, which is the organizational span of the process, let's say how much the process is cross-functional, as we know that processes are cross-functional, but of course this shouldn't be pushed too much, and mostly how responsibilities, role and separation of activities are defined among the different people taking part of the business process. Dealing with this last aspect, we then have a strong focus on the resourcing and the capabilities related to the business process. Of course, we could also focus more on resources characteristics, and for each resources which is part of the process, it is necessary to evaluate if there are the needed competencies to enable a correct, an efficient, and an effective execution of task and operation, and how much these resources are saturated in order, of course, to prevent eventual unavailability. Then we have, let's say, the performance management aspect. On the performance management side, levers of improvement can include, first of all, the performance control strategy. We discussed a lot about this and about the fact that performance measurement system should be aligned to the process view of the organization and should be able to measure the performance dimension which are strictly related to the firm critical success factor. If they are not, of course, an intervention, a redesign of the performance measurement system is required. Then it is essential also to verify the methods and the technology used, as of course performance must be measured and controlled properly in practice, not just in theory. And this can be made through the design and the implementation of a proper infrastructure for the performance measurement system. Finally, we have the process automation lever. When we talk about the process automation lever, we are including essentially as possible information and communication technologies supporting process activities, three types of systems. First of all, the communication system. Communication system are all that technology, application, infrastructure that enable a communication between the people involved the process, making this communication fastly and very efficient. Then we have what we call the control technology, meaning that, of course, the IT usage and the technology implemented in order to support the process should be consistent and align with the process logic. For example, information technology, information system must be parameterized according to process managerial characteristics and not just with standard model or benchmark that doesn't make any sense with the specific process functioning within the company. Finally, we have the proper ICT technologies and infrastructure, included all the methods and the support instruments for carrying out the process and the assessment of these methods and support instruments in terms of consistency with the process they need to support. If all of this is clear, let's focus our attention on this last, but not least, aspect and lever to improve business processes. As we already, let's say, have seen in the previous module, ICT can support business process management essentially in two ways. On one side, helping with the business process modeling, like we saw through the tools of business process modeling, like Signavio that you are using for your assignment. Or they can be useful in order to run, support, or execute activities and processes. Of course, in this module, we will focus on the second type of support, as we already deal with the support on the model, let's say, aspect. And in particular, when we speak about the overall information and communication technology supporting business processes, we refer to them with the name enterprise system. Enterprise systems are all the information system supporting business processes, and I mean the most, let's say, diffused and the most important and the most renewed information enterprise system are enterprise resource planning, customer relationship management, supply chain management, data warehouse, and business intelligence. I mean, of course, other typologies of enterprise system exist, like intranet and extranet, product configuration, radio frequency identification technology, and so on. But from now on, our focus will be on this type of enterprise system. In particular, within this type of enterprise system, we distinguish two categories. What we can call the transactional enterprise system, like enterprise resource planning, customer relationship management, supply chain management, and analytical enterprise system, like data warehouse and business intelligence. Let's focus on transactional enterprise system and on the difference with the other category, the analytical system. These transactional systems are also named, as you can see, online transaction processing, or LTP, or transaction processing system, TPS. What's the meaning of let's say, transactional enterprise system? online transaction processing system are all the systems that support the operational processes of the organization. And how they support these processes? By performing activity of these processes and recording daily routine transaction necessary to conduct the business. Example of transaction of operational processes are payroll, order entry, inventory picking, inventory check, and so on, invoice receipt, and so on. All of this as example of operational transaction. So, Transactional Enterprise System, or OLTP, record in what we call Company Database Management System all the transaction that daily happens in the company. Here you can see an example of a database created by a transactional process. This system, for example, in our example, allows a professor of a university or high school or a secondary school, I don't know exactly, but allow the professor to insert for each student of the course the final grade with already some previous information already associated to this field, like the ID, the course name, and so on. Finally, this creates a final database with, 100,000 millions of lines which represent information recorded thanks to the functioning of the grading process in the university. This is very different if we compare the functioning of transactional enterprise system to the functioning of analytical enterprise system, which are also called online analytical processing, OLAP. These systems are all that we can define as decision support information system. So all the systems that support complex decision by providing aggregation and disaggregation of data coming from the transactional system. To do that, they use what we call data warehouse. Data warehouse are, let's say, advanced database, which starts from information stored in database management system and elaborates this transactional information through queries and further transformation, extracting and consolidating this type of data, but without modifying, let's say, the original number, the original information. Let's see an example, as you can see in the slide. A data warehouse essentially combines information from several sources into one comprehensive database. In the case listed, in the business world, a data warehouse might incorporate customer information from a company's point of sale system, like for example the cash registers of Walmart, its website, its mailing list, and its comment cards. So putting all together this information, the data warehouse can extract further and more value-adding information which goes beyond the traditional transaction that interests the point of sales. Not only, alternatively, it might incorporate all the information about employees, including time card, demographic data, salary information. So if you don't want to make the analysis on the final customer, we can also make analysis of employees. So by combining all of this information in one place, a company can analyze its customer or its employee in a more holistic way, ensuring that all the information available and coming from the operational processes are included and considered in this type of elaboration. Data warehousing also makes what we call data mining, which is essentially data warehouse enabled data mining, which is essentially the task of looking for patterns in the data that could lead to higher sales and profit. So by extracting and integrating and analyzing transactional data, the data warehouse can identify some patterns, some causal linkage, some trend in the data, and then make the company understand if these trends can be used as a way to improve revenues or reduce costs. here there is a summary table that, let's say, summarize the main differences between OLAP system and OLTP system. As you can see, this table clearly restates how OLAP are all the systems that support decision-making process, while OLTP are all the enterprise systems that support and then let's say, are integrated in operational and transactional processes of organization. If it is still not clear, let's give you a visual representation of how database management system and data warehouse coexist in a company. Operational processes are supported by operational modules, so transactional enterprise system, and generate transaction. These transactions like payroll, like orders, like receipt, like inventory picking, like this kind of stuff. These kind of transactions are included and feed the operational database, so the database management system of the organization. In order to use this, let's say, huge amount of information, there is the need to transform this information into something that can be analyzed or can be of more value. This, let's say, transformation is requested through queries by data warehouse, and the new value is stored in this type of database named data warehouse. This new information, new re-elaborated information, then fits at the point of start of the module that then support instead the decision-making process, in particular all the business intelligence module that are supporting the decision-making processes of organizations. Here you can see more in detail how enterprise systems are distributed in a company. This is particularly true for, let's say, a manufacturing company. For each step of the value chain, we have a potential enterprise system that support the process. For example, for design and engineering, we have a computer-aided design. For manufacturing, we have a computer-integrated manufacturing system. For procurement, we have the material requirement planning systems. For sales and distribution, we have distribution requirement planning system. For the whole chain, we have the product lifecycle management systems. For the whole supply chain management, so including also company interprocesses, we have supply chain management system, and so on. Here, now to better clarify what we said so far, that's what enterprise system can potentially cover. In particular, we can see that on one dimension, you have all the modules supporting specific units, function, or department, which are represented by these axes. You say administration, sales, procurement, design, production, HR, intranet, CRM, and supply chain management. Each one can then be deployed in one or more sub-package, supporting different parts of the process that interest the single department. This is what we call functional competencies. For example, for procurement, we have modules supporting purchase order management, inventory management, warehouse management, and transport management. On top of this, we have instead all the modules specifically dedicated to the decision-making support. This module, like planning and forecasting, management control, business intelligence, and reporting, extracts data from, let's say, the transactional modules and elaborate reports, make business intelligence analysis, support management control, and give planning and forecasting estimation in order to feed the decision-making activities of the organization. In this slide, you can see also possible names of packages sold by vendors on the market to cover the different processes. I mean, this is just, a comprehensive view of what vendors in the market offer to cover and support the different process of an organization. Like, for example, for materials planning and management, we can find a strategic supply chain design module, a material requirement planning module, a forecasting and life cycle planning application, safety stocks planning, customer collaboration, and identification and tracking technologies. Pay attention to the fact that if all of this is true, and process automation and ICT really are of a great lever for process improvement, don't think that the conclusion is that the best role in company is automate all that is possible. Because please always remember that automation has also some drawbacks. Like, for example, implementing technologies, enterprise system costs money to the organization, is an investment. Then, second, they change how process function and are deployed on the organization. So they force organization to modify their way of operating. So there is a capacity of organization to adapt that is not immediate. Finally, they force processes to follow pre-established path and best practice, thus limiting the possibility to customize the execution of processes according to real-time information. So, by implementing information system and enterprise system, you miss some possible peculiarities of existing practices. If this, let's say, overview is clear, what I want to do now is to focus on a particular type of enterprise system, what we call the enterprise resource planning systems, which are one of the possible enterprise transactional systems that a company can adopt. To do that, let's start with a famous case. In the 80s, the accounting department of a famous organization, Ford, was composed by 500 people, which were all focused in managing accounts payable coming from all the potential Ford vendors. The process started when a purchase order was sent to a supplier. Then, once the purchase order was received, a copy were also sent to the accounting department. Then, once the goods were received, an employee, let's say in the goods reception office, filled out a document with products description and sent this out to the accounting department. Finally, the supplier sent the invoice to the accounting department, which has now in its hand three documents: the purchase order, the reception form, and the invoice, which need to be checked and aligned. If all is okay, the payment is authorized and then the process can come to an end. With this functioning, the process at Ford, let's say, revealed to be very, very inefficient and also ineffective because the 500 employees in the accounting department were spending most of their times in checking the three documents and evaluate if they were alignment and if they were not, the possible cause of eventual misalignment. It seems incredible, but at the time, to solve eventual misalignment may took also weeks. So there was a lot of waste of resources and human resource time because they were just checking what did wrong during the process. Ford management was convinced that by automating some of the activities of this process, human resources needed for managing the whole process could have been cut off 20%. This idea came, let's say, in mind for the managers. Considered let's say the benchmark at the time with Mazda, which was newly acquired by Ford and who was able to manage the same process in its company by just using 5 people and process automation. So, with this idea in mind, Ford decides to completely re-engineer the process. In particular, first, when a purchase order was issued, first things to be done by procurement people was to insert in parallel this information in a database, so in an enterprise system. Then, once the supplier would have sent the article and the goods to the goods reception office, let's say the employee in this office, we first have to check on the system that the goods arrived were overlapping with the information inserted for the purchase order previously put in the system. And in case this is okay, the employee accepts the goods and confirm through the system that the goods are arrived and are compliant. By doing this, let's say, good reception is registered and visible to all the actors, and an actual, let's say, implicit virtual invoice is generated. In case instead the goods were not compliant or there was no order put by the procurement people in the system, the employee in the goods reception office was not authorizing good acceptance and actually send them back to the supplier. Once the goods are authorized and let's say the virtual invoices automatically generated, the accounting department access the system and just check that all the information are in the database and all is okay. Once verified that all is okay and let's say a green flag is present, the accounting department just have to authorize the payment and the process can come to an end. Of course, now the process is much more easy and simple. In particular, with this new configuration, Ford needed less human resources, from 500 to 125. And all of this thanks to an integrated information system able to share and to integrate and to make information visible to all the actors of the process during all the duration of this process. This example shows exactly what an enterprise resource planning system actually does in companies and which are the potential advantages of having a system of this in place. If we try to summarize the levers of business process reengineering that have been implemented in the Ford case, we can of course see that process automation clearly represents the key choice and the key point for process improvement. As now, the process can rely on an integrated system supporting the whole process and the whole information, so that all the information are shared, visible, and real-time accessible to all the actors participating to the process. In particular, if you want to let's say, to reason on some number, in the re-engineer process, information is available to all the actors during all the process. There was 75% reduction of head count in participating in this process. Material control flow was simpler and the financial information given and registered from the process were more accurate. And purchase requisition were faster, and most of all, there were less overdue payments, so higher level of service to, let's say, the final customer, which is actually now the vendor. So Less overdue payments means supplier more satisfied. The 4Ks report exactly which are the expected benefit of the implementation of an enterprise resource planning system, which can essentially be defined as a suite software application, including modules supporting the execution of internal organizational transactions, vertical or horizontal, but part of company business processes. We can in particular say that ERP systems share common processes and data model, and covers in doing this all the operational and transactional end-to-end processes like finance, HR, production, distribution, sales, order fulfillment, and so on. And more, ERP applications are able to automate and support this type of processes using a multiple industries approach. So they are flexible and they can be adapted to different industries' peculiarities. When we talk about suite of the enterprise resource planning, we refer to the possible programs that can be sold together in a single package and that can be formed and that can form the, let's say, enterprise resource planning system architecture. Which type of suite we have within an ERP system? We have industry solution, also called vertical suite, which are modules and applications that are specific of a business sector. Like, for example, here you can see, if I am a project-based company, for example, an engineer company, I will need an application for project planning and controlling of activities. And I have industry solution supporting this type of need, this type of activities which are specific of a particular business. Then we also have cross-industry solution, also called horizontal, which are instead modules that are valid for different business sectors, so are invariant across industries. And of course, these are what we can call the standard suite of an ERP system. We have standard suite, and this standard suite can then personalize, customize with industry-specific suite. Pay attention that we have also what we call extended solutions, meaning advanced module and application which can integrate the actual ERP system horizontal and vertical, like application and programs for product lifecycle management, for customer relationship management, and for supplier relationship management. Here we can see, let's say, the three value drivers of an ERP system. First of all, ERP systems are very important resources and levers for improvement because they are able to share and integrate information coming from the operational processes between all the actors of the processes, which can access this data in real time and from different locations. Then, we already talked about this when we described the suite. An ERP system is characterized by extension and modularity, meaning that it can be extended with many suites and applications, making this adaptable to different companies and requirements. Finally, a not neglectable aspect, an ERP system can propose and have as embedded predefined business process model, from which the company can start from to customize then the process. So we have a benchmark, we have a point of start, the modeling of a standard process which can be then customized according to company needs. Pay attention that thanks to the suite extension characteristics, ERP enable intercompany process management. In particular, if this is our company, thanks to the extension of the module inbound and outbound, so for supplier relationship management and for customer relationship management, our company is able to connect with its main supplier and with its main customer, realizing a digital or electronic integration. Thus, let's say, enabling an intercompany process management in, let's say, the modern supply chain and value chain perspective of a company. Before to conclude, I just would like to give you some details about the market of enterprise resource planning system. One of the most diffused model or framework or tools to map ERP vendor is what we call the Gartner Magic Quadrant, which is this matrix. This matrix is the Gartner Magic Quadrant. Gartner is a famous IT consultancy organization, and it is famous for many, let's say, benchmark and tools for analyzing market. In particular, the Gartner's Magic Quadrant is very diffused. In particular, this metrics classify the solution offered by vendors in the market according to two dimensions. Let's say the effectiveness and the ability of the execution of the process to the ERP, and the completeness of their vision, meaning that how much they are flexible in supporting this type of processes. This is the last updated version of 2015. We can see that the best position, meaning high completeness of vision and high ability to execute, are the SAP Business Suite and the EIFS application suite. Then just have a look also at which is the level of industry coverage assured by the different typologies of enterprise system. As you can see, SAP and Oracle solution are those assuring the broader coverage in terms of industry. So they are the most completed enterprise resource planning. So if you go through SAP and Oracle, you will find a lot of vertical suite adapting to different business sector. We have also to notice that independently from the vendor, let's say the most covered and the most let's say supporter industry is manufacturing, while still today there are some issues in supporting processes in the financial insurance industry, also due to the regulated and confidential nature of this type